So what we're doing now is we're taking what we've learned about quadratics, and we're going to be doing story problems. All right. So since these problems have a context to them, that means that when we write the answer, we have to write the answer in sentence form. We're going to write the answer within the same context that the problem was given to us in. So let's go ahead and graph this first one. So I'm going to hit y equals, and it says negative 4.9 t squared. I'm going to use x's though, so x squared plus 27x plus 3.7. So the situation says we have a water balloon that's being catapulted into the air, and it's modeled by this equation, and they want us to draw a sketch of that so we can go ahead and graph it on our calculator to see what it looks like. And headphones out, right, Matthew? Thank you. All right, so a lot of students have a hard time figuring out how big their graph needs to be able to see these. So if you hit second graph, then you can see the table. And when you look, there we go. When you look at the table, you can kind of see what x values and y values are logical for the problem. So if you think about the context, we're launching a water balloon in the air. It doesn't make a lot of sense for a water balloon to be in the air for 25 seconds, right? It should already have hit the ground by then. So if you look, you can see here are the x values, that's the time. Here's the height of the water balloon off the ground. And what's the highest height that you guys can see? 40.6. Yeah, so when we look at our window, a window for the x's for the time from negative 10 to 10 is fine. That's going to make it like we can see the graph clearly. If you think about the y's, that's going to be the height. And I want my height to go above 40 because I want to be able to see the whole graph. So I'm going to change my y max to be 50. So everyone in the window, go ahead and click window. Change your y max so that it's 50. And I should hear some typing because every single person's following along. All right. So now you can go ahead and hit graph, and we should be able to see everything. All right, so we're going to draw a sketch of this. And your sketch doesn't, that's a bad sketch. Your sketch doesn't have to be perfect. Mine looks pretty terrible. But as long as you get most of the stuff. So this is the y-intercept right here. Does anyone know what that is in the context of the problem? Thinking about a water balloon that's being catapulted into the air, so what is that? That's the starting point. So that's like the catapult with the water balloon sitting in it. It starts at a height of 3.7. So this is the launch, right? What is this part over here?
That's where it hits the ground.
Yeah, that's the ground. What's the mathematical term for that point?
Zero.
Yeah, they call it the zero of the graph. What's another mathematical term? X-intercept. Okay. What about up here? In the context of the problem, what is that? Yeah, highest point. And if we talk about mathematical terms, what would we call that? Vertex. What's another name for it? Max. So when we do these story problems, we're gonna look at the graph, but then we have to think about in terms of the context of the question, what is it actually asking for, and then we can use the calculator to get all of the answers for us, and then we get to be kind of lazy with our math today because all the answers are coming from the calculator. So if I write the equation y equals, because in our calculator it's written in terms of x and y, so I'm going to go ahead and write this with x's and y's. The x's are replacing the variable t, so what are the x's standing for? Time. And then what is the y standing for? Height. Okay, so that's going to be good to remember when we do the rest of these problems trying to figure out what's what. So number one says how high. So are you finding a y value or an x value?
Y.
Yeah, you want to find a y value. How high is the balloon after 1 second? So they're asking you to figure out what y is when x equals 1. So there's something, if we look at our menu, if we do second trace to go to our menu and think about all the things we can do from that menu, which is the one that allows us to plug in x values? Yeah, number 1 does. Number 1 says, okay, what x value do you want to plug in? And what x value should we plug in for this one? 1. All right, so I'm going to write off to the side that for this one I did second trace. number 1, and I plugged in x equals 1, and the point that it gave me as an answer is 125.8. Okay. So in the context of the problem, I'm going to say the height of the balloon after 1 second is 25.8 meters. Yeah.
Can't you just check the table?
You can check the table too. So the nice thing about using that option is if they give you a decimal, then you can plug in a decimal really easily that way. The table, you'd have to change how your table works to do that. Yeah. All right, the next question says, for how long? So are we solving for an x or are we solving for a y? We're solving for an x since it says for how long. How long is the balloon more than 30 meters high? So if we can picture this, I'm going to go ahead and draw it. We know that we know that we could see from the table that the highest point is somewhere around 40 meters, right? So we know that on the way up to being 40 meters, it's going to hit 30, right? And then it's going to keep going up and hit 40 meters, and then it's going to come back down, and it's going to be 30 meters again. Does that make sense? It's going to hit it twice, on the way up, on the way down. And we want to see the time interval between these two things. That makes sense? So we want to find both of those. Now, if you look at the menu, if you do second trace, there's no item in that menu that allows you to plug in a y value. The place that we plug the y values in is actually where we graph. That's the y equals button. So go ahead and hit y equals. And for y2, we're going to plug in 30. And once you graph it, it adds a horizontal line, and the horizontal line is at a y value of 30. So we want to find this point. It's going to be some sort of x coordinate and then a y coordinate of 30. Thanks. And then we want to plug in this point, which is going to have some sort of, or we want to find that point. It's going to have some sort of x coordinate, and the y coordinate is going to be 30. So we want to figure out what time it hit 30 on the way up and what time it hit 30 on the way down. So we're going to go to our menu. We're going to hit second trace, and then which option do you think you should use? Yeah, number 5. You want to see where those two lines cross. So go ahead and hit number 5. A lot of students don't know this about the intersect button, but you don't actually have to move the cursor much. You just have to be closer to one of the intersections than the other one. So right now my cursor is over here. It's closer to the one on the left. So if I press enter, 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 it's going to find that one on the left for me. You don't even have to move it. So that first intersection is 1.264. So 1.264 is where it starts being 30 meters high. And then we're going to do second trace again, number 5. And I don't have to go all the way over to the intersection. I just have to be closer to the one on the right than I am to the one on the left. So you just have to get, so you're more than halfway there. And then press enter 3 times and it will give you the other one. All right, so it starts being 30 meters high at 1.264 seconds. It finishes being 30 meters high at 4.246 seconds. So how could we answer the question? What should we do?
So in the context of the question asked, would you say that the balloon was higher than 30 meters for 3 seconds? And then
Is it exactly 3 seconds? It's about 3 seconds.
Yeah,
How could we figure out? What math are you doing in your head? Yeah, you're subtracting them in your head. So we can go ahead and just subtract them, and then we'll get a more accurate, you're right that it's about 3 seconds, but we'll get a more accurate number if we actually do the subtraction. 1.264. And your decimal would kind of depend on how many decimal places you used from your answer. So if some of you guys used 2 decimal places, your answer might be a little bit different than mine. So how should we write the final answer? And the balloon is above 30 meters high for 2.982 seconds. Yeah, because we rounded. It's not, most people know in this situation. You could put about, and that would be more accurate. Like if you're getting semantics, if you're being really picky about your words, then you should put the word about. But most people would look at this and be like, it's very approximate because you got lots of decimals in there. Yeah. It's kind of like how whenever I put an approximate answer, I probably put a squiggly equal sign, but I don't expect you guys to do it. Technically, you always should, but we kind of all know if we're putting the decimals, we round it. Yeah.
So since we should say for about 2.982 seconds, still need to say for about 3 seconds. Maybe.
Yeah, it depends about the level of precision the person wants.
Either way,
So it is still about, you're right, but if they say the level of precision they want is 3 decimal places and you say about 3 seconds, then you're not following the precision of the problem. So the difference here is not, I'm not saying about and I'm not saying I rounded or didn't round. I'm saying that the level of precision we want is multiple decimal places. Yeah. So, and the reason we typically would not say about 3 seconds or 3 is it just, we don't like, in math, we like to be at this level accurate enough to recognize that you don't have to round everything to a whole number, that decimals are okay answers to have. Yeah. All right, the next question, or let's write down our instructions since these are our notes. We might look back and wonder how we did this one. So second trace number 5 is what we did. And I would say of everything that we are looking at doing today, number 2 with this method of solving is probably the hardest one we'll have. This is the one that students most often get wrong because they forget that they can just graph it. Yeah.
Me.
Oh, you were just fixing your bracelet?
No, I was, sorry, I didn't really catch how you get the second number. I mean, I know you have to use the intersect thing, but...
We just scrolled, so the cursor, it will find the one that it's closer to. So at first the cursor was over here, so we just pressed enter, 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 and it automatically went to this one. To get the second one, I just scrolled past halfway, and then I pressed enter, enter, enter again, and it got the second one for me. Yeah. So you just have to be closer to that one. Yeah. Okay. Any other questions? Yeah.
Do we have to use second trace every time?
To do the problems, not necessarily. It depends on how well you know your calculator. But for a lot of them, yeah, because it has the menu of different things you can do. So we'll come back to that a lot. Yeah. All right. The next one says, what is the maximum height? So are they asking for an x value or a y value? A y value, because y is height, right? What is the maximum height of the balloon? So where in the picture are we looking?
The vertex.
We want the vertex. And what's another name for the vertex when it's at the top? Yeah, we're looking for the max. Okay, so we're going to do second trace. And which option?
Oh, 4.
Number 4, yeah, so second trace. Number 4. All right, and so when you do this, you're looking for the maximum height. There's your vertex. You have to do left bound and right bound for this. So your left bound should be to the left of the highest point, and your right bound should be on the right side. So we'll go over here for left bound, and then over here on the right side for our right bound. All right. So I'm getting that my point is 2.755. 40.894. So if that's the point of the vertex or the maximum, then how would I answer that question?
The maximum height of the balloon is 40.894 meters. Do you have to draw the whole graph thing every time?
I'm going to ask you to do it to start with, so that I know that you understand what you're doing. And because these questions are completely calculator questions, it's hard for me to grade them if you, like, either I'm like, they completely didn't know what they were doing, or you drew a picture and I could kind of see what you were thinking. So for us, since we're first like going over this, I would like a picture every time because it kind of helps me see what you're thinking. In a few months, when you guys have done this a bunch and you kind of know what you're looking for, I'm not going to expect any work. I'm just going to expect you to get it real quick. All right. Sometimes they'll phrase the question as like, when did the balloon meet or reach that maximum height? And if they're asking it that way, they're asking for the x coordinate. So this question is typically phrased both ways, and they want the point, they want the x coordinate and the y coordinate. They just want them in answer to different questions. So you'll notice that that question is pretty common to be asked. Any issues on that one? Does that one make sense? Okay. So the next one says when. That's the first word. So what are we solving for? An x. When will the balloon burst as it hits the ground? Where in the picture are we looking? The end of the graph, right? This is where it hits the ground, and that is the X-intercept, or the 0. It's also called a 0. So we're going to hit second trace, and then which one are we looking for? Number 2, yeah, the 0 of the graph. Does anyone remember why it's called the 0 of the graph? Yeah, that's where it's the y value is 0. So the function itself equals 0 at that point. All right, so they're going to ask us for left bound, right bound. So here's our left bound. Here's our right bound. So left bound is somewhere on this side of the graph. Right bound is underneath the x-axis. And I got the point 5.6440. Okay, so what should I write? Yeah, so think about your units, because you've got x was time and y was height. So what would the units for time be? Seconds, yeah. So 5.644 seconds. There we go. Okay. Okay, so this sheet that I gave you that looks like this was kind of meant to be used as like a cheat sheet that you could kind of refer to today in case you get stuck. So the y-intercept, I'm just going to go ahead and take these instructions here that we wrote down on the side and add them to the sheet. So if you need to find the vertex, that's where you're doing second trace number 4. And they kind of give you the hint here that it's the x value if they're asking a when question, and it's a y value if they're asking a how high question, if they're talking about the height. We didn't do one where we needed to find the y-intercept, but how would we have done that?
Second trace 1.
So second trace number 1, and when you do number 1, it asks you what to plug in for x. So what would you plug in? 0. Okay? And whenever you're looking for a y-intercept, that's actually answering the question, how high off the ground did the object start? So for the problem we just did, it was 3.7 because that was how high the object was when it launched. If they're asking you a question like, how high is the object after a certain number of seconds? That's like number 1. So for this, we're going to do second trace number 1 again, but you just plug in whatever the number is that they gave you for time. So here I'm going to write second trace number 1, and then x equals however many seconds they ask you to do. Down here they have 2 things drawn. They have the negative 0, or the negative x-intercept, and the positive 0. Why would we never look for this one over here?
I was never going to go back.
Yeah.
Time to go back.
We don't go back in time, right? I mean, there's movies about it, but so when we're doing a story problem, this answer is called extraneous. It's like an extra answer that doesn't make sense. Like mathematically you can find it, but it doesn't make sense in the problem. So we just ignore that one. So over here, this is going to be second trace number 2. And they phrase these questions 2 different ways. It might be phrased, when does the object hit the ground? And I think that's really easy to answer. The other question that sometimes throws students off is when they ask you how long was the object in the air. And so that's when it's hitting the ground. So that's when it stops being in the air. So same answer, just 2 different ways of phrasing the question. So this is kind of like, in case you get stuck, you can look at this to kind of help you out. Does that make sense? Okay. We're going to skip the second example on the notes and just skip to the practice worksheet. So the assignment asks you to round to 2 decimal places. So let's make sure we do that. And then the assignment also says to write a sentence for every single problem. So make sure you do that too. So here, this one says a rock is dropped on the surface of Mars from a height of 100 feet. And then they give you an equation. So let's go ahead and figure out how to graph that. So I have negative 6.5 x squared plus 100. And to figure out how big we should make our screen, we're going to go ahead and hit second graph. We're going to look at the table. So I don't know how fast things fall on Mars. It could be real slow. But if you look at this, you can see that at 0, the height is 100 feet, because this, the rock does not get thrown in the air and then drop down. It just drops straight down. It's dropping from a height of 100 feet. So you can see it's dropping, it's dropping, it's dropping. And then somewhere between 3 and 4 seconds, I know it hits the ground. How do I know that it hits the ground right there? Yeah, it goes negative, so it must have hit 0 at some point. So I know my x values don't have to be any bigger than 5, so a normal window will work just fine. But I do see that my highest y value is 100. So when I hit the window, if my highest y value is 50, am I going to be able to see the whole thing? No. So I need my highest y value to be bigger than 100. So, and there's no right answer here, 110, 120, 130. If you did 500, you could, but it might make your graph look weird because it's really high up. Now, when I graph these, I do not like when my x-axis is that far at the bottom of the screen because it makes it a little bit harder to find the x-intercept. If you guys remember when you do the left bound and right bound, it has stuff printed at the bottom of your screen. It makes it harder to see. So whenever I have a window this big, I go down and I make my y min a bigger negative number, and that just makes it so my x-intercept, or my x-axis is not the bottom of the screen. It makes the x-intercepts easier to find. So there we go. All right, so we can go ahead and draw the picture. And the x and the y mean the same thing they did last time. It's pretty common for them to be height and time. All right, so this point up here represents what in the context of the problem? It's the maximum height. What else is it? Yeah, it's where you dropped it. And then what's this point down here?
This when it hits the lands.
Yeah, so that's where it lands on Mars. All right, so if they ask the question, how long, are we solving for an x value or a y value? X. How long? Okay. How long will it take for the rock to hit the surface of Mars? So what are we looking for?
It's looking for when it hits 0.
Mm-hmm. So what's that called? Yeah, it's called the 0 of the graph. What's another name for it? X-intercept. So we're doing second trace, number 2, yeah, for the x-intercept. Intersect is a similar word, but it's not the same. Yeah, so x-intercept would be number 2. And when we do the X-Intercept, there it is. We're going to do left bound here and right bound down there. So there's my left bound. And this time they're only asking for 2 decimals, so please only write 2. And what should I write for my sentence?
The rock is the surface of Mars at about 9 to 2 seconds.
How about the next question? It says how high. So that how high means it's asking for y. So how high in the air is the rock after 2 seconds? So what do we do? So second trace,
And hit 1.
number 1,
And then 2.
plug in 2. So what should I write for my sentence?
At 2 seconds, the rock is 74. What is
The rock is feet.
feet?
74 feet in the air. When will the rock be, so it says when, what are we looking for? An X. When will the rock be 50 feet from the surface of Mars? Yeah, y equals 50, and how do we plug that in? Oh, yeah, y equals. Okay, so the y equals screen, and then for y2, we'll plug in 50. Mm-hmm. And we do second trace. We're looking for where those lines cross each other. And am I looking for the one on the left or the one on the right?
One on the right.
Do we need both of them or just one of them?
Just one.
Just the one, right. The left part of the graph really shouldn't be there for the context of the problem. It doesn't make sense. So I'm just going to move a little bit closer to the one on the right, and then I can press enter 3 times, and then it will find it.
What function do you use to find that?
Number 5. So second trace number 5, the intersect. So we have the point 2.7750, and we're going to say the rock is 50 feet from the surface of Mars at 2.77 seconds. How do we feel about those problems? Do we see how we can use a calculator? Yeah, they're not too bad. Okay.